Okay, a quick summary about the previous episode, which is electric motor. Electric motor, it is a device that converts electrical energy into kinetic energy, okay? So we're going to start off with the front view of the electromagnet. We have the electromagnet or the solenoid over here, okay? We have the coils around it. I'm going to take the front view. This is one of the loops. See this loop? This is one of that loops. But imagine this is looping one of this electromagnet, okay? So I took one part of the front view, okay? The current is still the same, current is going, but this is the electric motor, okay? Now the electric motor, this loop is connected, each one of these loops is connected to a commutator. It is connected to brushes, which is connected to a power supply, and there are magnets around it, okay? We're going to look over here why we use a commutator and why are there magnets around it, okay? Basically how this works, okay? We said that it converts electrical into kinetic energy. Electrical energy is supplied from the power supply, always conventional current, positive to negative, positive to negative. So electrical energy is supplied from the power supply, goes to the coil needs to spin to have kinetic energy. But there's a problem. The problem is that the magnetic field of the coil, because we said the coil is what? The coil is a current carrying wire. In the beginning of this series, we said any current carrying wire has a magnetic field around it. The magnetic field around this coil, which is north here and south here. How do I know this? Look at this one. Where is the coil turning back? So coil is turning back. Magnetic field is north over here, some points here, south is the other side. So this means this is the north, this is the south. This is the north, this is the south. Okay? From this north and south, if I put magnets of opposite polarity, okay, opposite polarity, what will happen? There will be magnetic force of attraction and repulsion. It will cause the coil to make a half spin, okay? But then like poles will come alike, so it will make a half spin back to its original position. Then half spin, then half spin. So it will just keep making a half spin, okay? It will not make a full 360 spin, which we want. One can say, I will keep switching the magnets over here, so it will make a full spin, okay? But this will take too much effort. Instead, you can use a commutator. The commutator is something that will keep spinning to reverse the direction of the current. If the direction of the current is reversed, the direction of the magnetic field is reversed, because what produces the magnetic field? The current. So if the current is reversed, magnetic field is reversed. If the current produces B magnetic field, A prime current will produce B prime magnetic field. So in this case, this is the problem that we are going to solve with the commutator. On the figure above, by the right hand rule, okay, curving your fingers like this over here, north is here, south is here. So this is the magnetic field of the coil. North is here, south is here. But when placing magnets on both sides with opposite polarity to the magnetic field produced by the coil right hand rule. So this is north, this is south, by the right hand rule on that coil. If I'll put magnets with opposite polarity, south and north, due to the magnetic force of repulsion between these, it will make a half spin. But now, like poles will be together and it will go back to its original position. There is no 360-degree rotation, no kinetic energy produced. To solve this, we will use a commutator. Commutator will reverse the direction of the current, so it will reverse the magnetic field, so the magnetic field will not be north and south every time. It will be south and north and south and north, to allow a full 360-degree rotation, preventing the problem of the motor doing every half spin due to the attraction and repulsion forces, okay? We're going to take the definitions and the parts of the commutator as their definitions and functions in the upcoming episode. So I know this is the most confusing part of the motor. If you have understood this part about why we're using the commutator to reverse the direction of the current, to reverse the magnetic field of the coil, okay, to allow a 360 rotation. Because with this scenario, if it's only going to make a 50 rotation, half spin, north and south, like poles, like half spin, then again half spin, okay? So we use the commutator to reverse the direction of the current, to reverse the direction of the magnetic field, to make a full 360 spin. This is the most confusing part about the motor. If you understood this part, then the upcoming series of this electromagnetic series is going to be much more easier. So yeah.